السلام عليكم ورحمة الله وبركاته الأبناء الأعزاء. Last lecture we learned some good information about the new functions, hyperbolic and inverse hyperbolic functions. We started with the hyperbolic functions which are defined as certain constructions of the exponential functions e to x and e to x. Remember with me, we defined the functions sin x as e to x minus e to minus x divided by 2, cosine x as e to x plus e to minus x divided by 2, tang x as sin x divided by cosine x, or e to x minus e to minus x divided by e to x plus e to minus x, where 2 cancels 2, cotang x, which is the reciprocal of tang, which means cosine divided by sine, or e to x plus e to minus x divided by e to x minus e to minus x. Then sec x, which is the reciprocal of cosine, which is 2 over e to x plus e to minus x. And finally cosec x, which is 1 over sine as 2 over e to x minus e to minus x. Also, we studied how to obtain the graphs of this function. Let us remember these graphs together. The graph of sine, if you remember, I told you it is like or similar to that of x cubed. It is not x cubed, but it is in one way or another similar to it, like this. Actually this curve is tangent at the origin to the 45 degrees line with y equals x. Okay, this is the tangent to y equals sin x at the origin. If you remember, I told you cosine x is called the catenary curve، منحنى الكتينة، السلسلة اللي بتلبسها البنات في أعناقهم، تدل منها ما شاء الله كده. This point is 0 1. As I told you, take care, the cosine curve is always greater than 1. We studied also tang. I told you, if you remember, it is similar in shape to that of tan minus 1. 2 horizontal asymptotes at y equals 1 and y equals minus 1. Cotang x has 3 asymptotes, 2 horizontal and 1 vertical as the y-axis. This is cotang x, and this is the reciprocal of tang. And sec x, which is the reciprocal of cosine. I told you all the values of sec are less or equal 1. Also has the x-axis as horizontal asymptote. This is sec. This point, maximum point, is 0 1. Finally cosec, which is the reciprocal of sine, like this. Also it has 2 asymptotes, one vertical as the y-axis and one horizontal as the x-axis. This is y equals 0, this is x equals 0. This is cosecant. And we also studied the derivatives of these functions. If you remember, we have a simple table y dash. For the function sine, its derivative is cosine. The function cosine, its derivative is sine. The function tanh, its derivative is sec squared. I told you the first three are positive, the second three are negative. Cotang equals minus cosec squared. Sec minus sec tanh minus sec tanh. Cosec minus cosec cotang. While in case of trigonometric functions, if you remember, sine x, its derivative was cosine, while cosine, its derivative was minus sine. Tan, it is sec squared. Cotang minus cosec squared. Sec x sec tan. Cosec x minus cosec cotang. As you see, plus minus plus minus plus minus, while in hyperbolic functions the first three are positive and the second three are negative. Now let us discuss a very important algebraic relations concerning with the hyperbolic functions. We have already studied that and proved that cosine squared minus sine squared, the golden rule, equals 1. Cosine squared x minus sine squared x equals 1. In fact, any quantity cosine squared to x minus sine squared to x is 1. Cosine squared x divided by 3 minus sine squared x divided by 3 is 1. Whatever the quantity here, not the angle, there is no triangle. These are combinations of the exponential functions, remember, no triangle. Okay, from which we can take more than one relation. For example, we can take sine to the other side, so cosine squared some quantity equals 1 plus sine squared of that quantity. Also we can say sine squared equals cosine squared minus 1. Okay, from which also the relation, let this called relation star. If we divide it relation star, both sides of it by cosine squared, you obtain cosine squared divided by cosine squared is 1. Sine squared divided by cosine squared is tan squared. 1 divided by cosine squared is sec squared. Also, this relation can be got in many forms. For example, we can send this to the other side, so 1 equals sec squared plus tan squared. While in trigonometric functions, sec squared minus tan squared is 1, and 1 plus tan squared, it was sec squared, and cosine squared plus sine squared is 1. Cosine squared 1 minus sine squared. Sine squared 1 minus cosine squared. You have to keep in mind these basic relations. This will facilitate the solution of very difficult problems. Inshallah, nothing will be difficult for you. Also, we can take dash to the other side and take sesh to the left side to obtain 1 minus sesh squared some quantity equals tanh squared of that quantity. You have to be capable of moving one quantity from one side to the other and so on. Don't keep in mind only one relation, but you can reshape this relation to use it as you want in the solution of your problem. Also we have very important relations, similar, not exactly as similar to what we studied in trigonometric functions. For example, sin x plus y equals sin x plus times cosine y plus cosine x sin y. This is similar to sin x plus y equals sin x cosine y plus cosine y sin x. Also, if there is negative sign, it will be here. Okay, let us prove for the positive sign. Let us prove for the positive sign. Okay, that is to say sin x plus y equals sin x cosine y plus cosine x sin y. Remember, these are not angles, they are numbers, 2, half, 3, and so on. Okay, now as you see, right hand side equals sin x, which is e to x plus e to minus x divided by 2 times e to y plus e to minus y divided 2 plus cosine x is e to x plus e to minus x divided 2 times sin, which is e to y plus minus e to minus y divided 2. We can take as a common factor 1/4. Okay, now e to x times e to y, e to x plus y, e to x times e to minus y plus the first is sin here is negative, sin minus, okay, e to x minus y, then minus e to minus x plus y, then minus e to minus x minus y. Then for this quantity we have e to x times e to y, e to x plus e to y, e to x minus e to x minus y, then e to minus x times e to y minus e to minus x minus y. Okay, as you see, this quantity cancels this, plus minus. Also this one, e to minus x plus y cancels e to minus x plus y minus plus, so this cancels this and this cancels this. Now e to x plus y with e to x plus y, which is 2e to x plus y. Now this with this, which is minus 2e to minus x minus y. Take 2 as a common factor. With 4 you have 2, and here e to x plus y minus e to minus x plus y. This is the definition of sin x plus y, which is the left hand side. This is completely similar to sin x plus y equals sin the first angle cosine the second angle plus cosine the first angle sine the second angle. Here with sine, these are angles. Here with sine, these are numbers. Remember this, please. If it is minus, also it will be minus here. Okay. Similarly, we can prove that cosine x plus y can prove that cosine x plus y equals cosine x cosine y plus sine x sine y. هو in trigonometry cosine x plus y equals cosine first angle cosine second angle minus the sign is reversed. Why in hyperbolic function the sign is the same. If it is plus, here is plus. If it is minus, here is minus. Okay? While in case of trigonometric functions, cosine x minus y, cosine x cosine y plus sine x sine y. Okay? Let us prove for the positive sign. Okay. Left hand side equals e to x plus e to minus x times e to y plus e to minus y, also 1/4 divided by 2 plus e to x minus e to minus x, this is the definition of sine, e to y minus e to minus y. Okay, let us simplify. E to x times e to y, e to x plus y. E to x plus e times e to minus y is e to x minus y. Then e to minus x times e to y, e to minus x plus y. Plus e to minus x minus y plus here e to x times e to y, e to x times e to minus y minus e to minus x times e to y, we have minus times minus is plus e to minus x minus y. Again e to x minus y cancels e to x minus y, e to minus x plus y cancels e to minus x plus y. This with this together twice, this with this together twice, so we have twice divided 4 times e to x plus y plus e to minus x plus y. This is half the definition of cosine x plus y, which is the left hand side. In the same way, we can prove that cosine x minus y equals cosine x cosine y minus sine x sine y, while cosine x minus y is cosine x cosine y plus sine x sine y. Okay? Now what about if x equals y? What about if x equals y? What about this? Let us discuss. If x equals y, so we have cosine twice x. If x equals y, we have sine to x, which is sine x cosine x. We said x equals y, and here cosine x sine x. So we have already proved that sine x plus y equals sine x cosine y plus cosine x sine y. If x equals y, so left hand side will be sine to x, while right hand side will be 2 sine x cosine x. Similar as trigonometric functions, sine to x equals 2 sine x cosine x. But remember, these are angles, these are quantities, numbers. Okay? Also, in case of cosine, a few seconds ago we proved that cosine x plus y equals cosine x cosine y plus sine x sine y. Now, if x equals y, left hand side will be cosine to x, and here cosine x, which is cosine squared x, sine x, which is sine squared x. While trigonometry, we have cosine 2x equals cosine squared x minus sine squared x. If you remember, we said cosine twice the angle equals cosine squared the angle or minus sine squared the angle, or cosine any angle equals cosine squared half the angle minus sine squared half the angle. Here, cosine any quantity equals cosine squared half the quantity plus sine squared half the quantity. Okay, this is number 2. But we already discussed and proved that cosine squared for any quantity minus sine squared for that quantity equals 1. Now let us make use of this. Okay, how we here in 2 I use for this relation. I take this relation again. As you see, cosine to x equals cosine squared x plus sine squared x. So cosine to x equals cosine squared x plus sine squared x. At the same time, cosine squared x minus sine squared x is 1. Now I can take cosine squared and set 1 plus sine squared. So here, instead of cosine squared, I write 1 plus sine squared, which is 1 plus 2 sine squared. Okay? While before we studied in trigonometry, cosine to x equals 1 minus 2 sine squared x. In trigonometry, take care of the difference. Also, we can take sine squared as cosine squared plus 1. Here, minus 1. You take sine to the other side and bring 1 to the left side. So, sine squared equals cosine squared minus 1. Substitute here. So, this also cosine squared plus cosine squared minus 1, which is 2 cosine squared x minus 1. Okay? So, we have this relation, or this relation, or this relation. Okay? I will write for you cosine to x can be expressed as either cosine squared plus sine squared, take care to x. If this x is x by 2, or 2 cosine squared minus 1, or 1 plus 2 sine squared. While in trigonometry, cosine to x equals cosine squared x minus sine squared x, or 2 cosine squared minus 1, or 1 minus 2 sine squared. Take care. Okay? No proof. No, you are not required to make proofs, but I want you to, when I use this final or what I deduce now, you already know how I obtained it. Okay? But you are not required for any proof. Okay? Don't worry about the proofs. But I want to make you sure that everything is easy, everything is possible. Okay? Now we have, inshallah, we'll obtain the last relation for the tangent. We know that tangent x plus y is sine x plus y divided by cosine x plus y. But we proved that sine x plus y is sine x cosine y plus cosine x sine y, and cosine x plus y we proved it is cosine x cosine y plus sine x sine y. Divide both numerator and denominator by this quantity cosine cosine. So in the numerator we will have cosine sine cosine divided by cosine cosine, so we have tan x, this will cancel this, plus we divide this by cosine cosine, so cosine cancels cosine and we have sine y divided by cosine y, which is tan y. Okay, now the denominator will be divided by cosine cosine. We'll have 1 plus sine sine divided by cosine cosine will result in tan x times tan y. This is very similar, not equal, not identical. In case of trigonometry, we studied before in trigonometry that tan x plus y equals tan x in trigonometry. We studied that tan x plus y equals tan x plus tan y divided by 1 minus tan x tan y, and if there is minus, this will be minus, this will be plus. Okay, while in case of tan plus plus plus, as you see, plus plus, minus minus minus, but in case of tan plus minus result is in plus minus, but here minus plus. Okay, now for this relation tan x plus 1, what happens if x equals y? If x equals y, what will happen? Now we'll have tan 2x equals tan x plus tan x, which is 2 tan x divided by 1 plus tan x times tan x, which is tan squared x. While in case of tan 2x equals 2 tan x, yes, but 1 minus tan squared x. Okay, take care of the differences between this function and the trigonometric ones. Okay. Now we are ready to enter the inverse function. This introduction is very necessary, is very important to understand well the inverse hyperbolic functions. I remind you some basic information about the inverse function generally, then we enter to the inverse hyperbolic functions. We have already studied that in a previous lecture, that sine minus 1 half equals 30 degrees. Or in other words, the angle 30 degrees has sine equals half. Has sine equals half. Okay? Or the sine of 30 is half. Okay? Sine minus 1 half equals 30 degrees means that the angle 30 degrees is the angle of which its sine is half. Okay? Or sine 30 is half. Okay? Okay. Sine 30 equals half. Okay? Okay. Generally, when we say y equals sine minus 1x, this means y is the angle of which the sine is x. Y is the angle of which the sine is x. Or x equals sine the angle y. This is the concept of the function and its inverse. Okay? No problem. Similarly, when we say y equals sine minus 1x, here x is the sine of the angle y, or y is the angle of which the sine is x. Again, x is the sine of the angle y, or y is the angle of which the sine is x. Now, x is the sine of the quantity y. X is the sine of the quantity y. X is the sine of the angle y. X is the sine of the quantity y. Y is the angle of which its sine is x. Y is the quantity of which the sine is x. Or in other words, x equals sine y. Okay? Similarly, when we say y equals cosine minus 1x, this means x equals cosine y. Y equals tan minus 1x, this means that x equals tan y. These are not angles. X and y are quantities. Y equals cotan minus 1x, x equals cotan y. Y equals sech minus 1x means x equals sech y. Y equals cosech minus 1x means x equals cosech y. Okay? So in a general way, as we studied before, when we say y equals f of x, I'll remind you, then this means x is the inverse of y. Okay? So y is f of x. Therefore, f minus 1, f, y is f of x. F of x equals what? Equals x. The inverse cancels the function as long as there is no any separation between these two operations. Okay? In the same way here. F of x is f minus 1y. So f minus 1y is y. So f cancels f minus 1 if there is no separation between them. Generally f minus 1 whatever here is that. F minus 1 f whatever here is that. Okay? You remembered? Alhamdulillah. Now, as we studied before, we can obtain the graph of the inverse function by many approaches. We concentrated on two approaches, as I told you before many times. To understand any function, we need its graph. From the graph, we obtain all the properties of function. Its domain, its range, its symmetry, its periodicity. Finally, we derive the derivative of this function. Actually, before to have the inverse of function, we bring the graph of the original function, and we have two operations, either this or this. The first operation, if you remember, back to right, if you remember. The second operation was reflection of the principal branch. Remember, we made before what we call the horizontal line test, which to be sure that when we have a horizontal line, it will intersects with the angle in one and only one point. You remember? For example, if you remember, I told you this is y equals x squared. By horizontal line, for the same y, I have two x's. This is one value of y, this. But I have x here and another x here, have the same image. This function has no inverse, but we take only one part of the function, consider it as the principal branch, if you remember, and find the inverse of it. If you remember, by back to right, again, this is the original, we have back to right. This now, it was y-axis, now x-axis. It was x, now y-axis. Before this was the y-axis, is now x-axis. This before was the y-axis, now it was the x-axis, now it's the y-axis. Okay? Or we find the reflection about the y equals 45, which will be like this. The same. Okay? Okay. Now, let us obtain the principal branch of the different hyperbolic function to obtain their inverse, or the inverse of the hyperbolic functions. Before obtaining or studying the inverse hyperbolic functions, I have to prepare the graph to obtain the graph of the new function or the inverse hyperbolic functions. If you remember, few seconds ago we draw. Now what we are talking about, principal branches of the hyperbolic functions. For what? To obtain the graph of the inverse function. Now, what are these principal branches? Let us see. For shine, we have this graph. What's the principal branch? If we draw any horizontal line, it will intersect only in one point and only one point. So the principal branch is the same. No change. No change. Excuse me. This is the principal branch. For cosine, no, it fails. Why? Any horizontal line will intersect in 2 points. So we consider only one part. This was sine. This is now cosine. We have only this part. And this is out of consideration. This is the principal branch. This part only. This is 0, 1. Okay? What about the branch? The branch, if you remember, like this. This is y equals 1, this is y equals minus 1. This is tangent. For any horizontal line, it will intersect with the curve in one and only one point, so the whole curve is still the branch part. The principal branch part is still the whole curve is the principal branch. Okay, what about cotangent? If you remember, cotangent was like this. This and this. So the horizontal line intersect in one point, so it is the same. This is for cotangent. Principal branch is the same as the original function. What about sech? Sech was like this. If you remember, no, it fails. A horizontal line intersect more than one point, so we cancel this part and don't take only this. This for sech. Okay. What about cosech? Cosech was like this. Any horizontal line will intersect in only one point, so it is the same like the original curve. The principal branch is the same, no change. Now let us enter the inverse hyperbolic functions, function by function. First one, inverse hyperbolic functions. First one, inverse of sine, y equals sine minus 1x. Okay, the original curve, this. Okay, this is x-axis, this is y-axis. Okay, now let us consider back to right. This and this. Again, this is the original curve. This is the original curve. Okay, to back, then to right, as you see. This was y-axis before. This is now x-axis. This was x-axis. Now this is y-axis. Okay. So the curve. This is for sine. What about that of sine minus 1? After back to this. This for the original. Now for sine minus 1, it is like this. Still 45 here. Okay, this is as you see from the graph. What is the domain? X belongs to R. What is the range? Y belongs to R. What is symmetry? Even. Oh, how come? This odd function. Okay, periodicity, oh, you talk too much. None. Okay, what is the derivative? Very, very simple. Y equals sine minus 1x. Derivative, up till now the derivative, okay, derivative. Okay, y equals sine minus 1x, which means x equals sine 1. Therefore, dx by dy equals cosine y, or dy by dx equals 1 over cosine y. What we proved is that cosine squared equals 1 plus sine squared. So cosine equals square root of 1 plus sine squared y. But sine y is x, so it is 1 over square root of 1 plus x squared. So d by dx for sine minus 1x is 1 over 1 plus x squared. Or generally, d by dx for sine minus 1 in function 1 over 1 square root 1 plus this function squared d function by dx. As you see, piece of cake. Again, for cosine minus 1x, y equals cosine minus 1x, which means that x equals cosine y. Okay, what is the graph? We said few seconds ago we'll consider only that part as the principal branch, only that part. Now back to right. This is x-axis, this is y-axis, okay, and the curve will be like this. So the graph of cosine minus 1 is like this. This point was 0, 1, it is now 1, 0. X cosine minus 1x going to infinity, infinity. Okay? Now, what is the range? What is the domain? What is the symmetry? What is the periodicity? Now, as you see, domain from 1 to infinity, x belongs to 1 to infinity. Range from 0 to infinity. What is symmetry? Even? No. Odd? No. None. Periodicity? Oh, none. What is the derivative? Y equals cosine minus 1x means x equals cosine y. Okay? Which means that dx by dy equals sine y. Okay? But sine y, we can obtain the reciprocal, or we can make an algebraic operation, then go to the reciprocal, the same, as you like. So dy by dx equals 1 over sine, no problem. But sine equals the square root of cosine squared minus 1. How come? Because we studied that. Cosine squared minus sine squared equals 1. So I bring sine to the right and 1 to the left. So sine squared is cosine squared minus 1. So sine square root of, as I told you, the last relations are very, very important for studying easily the inverse hyperbolic functions. This is cosine squared minus 1. But cosine y is x. So d by dx for cosine minus 1x equals 1 over square root of x squared minus 1. Okay? Where x greater than 1, as you see, actually x greater than 1. Okay? For the derivative, it must be greater. For the original function, no problem. It can start from 1. But for the derivative, can never be. This means that, what does this mean? It means that we have a vertical tangent at this point. It's clear. Here is a vertical tangent. Why? Because the derivative at 1 is infinity. And the derivative, as you know, it's geometrical interpretation, التفسير الهندسي بتاع the tangent at the point we are considered. Okay? Okay, so generally d by dx for cosine minus 1 any function equals 1 over this function squared minus 1 times the derivative of that function with respect to x. Okay. Third function, tanh minus 1, y equals tanh minus 1 x, or x equals tanh y. Few minutes ago we said that it is itself the principal branch. Back to right where the result is in. Do it by yourself, and you find it like this. The horizontal asymptotes will be now vertical asymptotes. These are x equals 1, these are x minus 1, and okay, this is for tanh minus 1x. Okay, as you see, domain from minus 1 to 1, domain minus 1 less than x less than 1, range minus infinity less than y less than infinity, symmetry neither nor, no, this odd function, periodicity none. Okay, periodicity none. What was the derivative? Okay, y equals tanh minus 1x. This means x equals tanh y. So dx by dy equals sec squared y. The golden rule, the rule for which we would that 1 minus tanh squared equals sec squared. So I can replace sec squared by 1 minus tanh squared. 1 minus tanh squared 1. But tanh y is x, so it's 1 minus x squared. So dy by dx, or in other words d by dx for tanh minus 1x equals 1 over 1 minus x squared, where x must be bound between 1 and minus 1. Actually it is. So generally d by dx for tanh minus 1 any function equals 1 over 1 minus that function squared that function by dx. Okay, where modulus that function must be less than 1, or other words between minus 1 and 1. Okay. The next function is tanh minus 1x, y equals cotang minus 1x. Okay, this means x equals cotang y. If you remember, the cotang was like this, as they said that its principal branch is the same. Using back to right, we'll obtain the new function cotang minus 1 like this. This is for cotang, this is for cotang minus 1. Okay, it is like this. X, as you see, domain x belongs to R except the interval from x equals minus 1 to x equals 1. Minus 1 and 1. Range, as you see, from minus infinity to infinity except the 0. Okay. What about symmetry? None. No. It's odd. Periodicity? I will not do. None. Derivative? Okay. Y equals cotangent minus 1x. Therefore, x equals cotangent y. Therefore, dx over dy equals minus cosecant squared y. Okay, but we studied that cosine squared minus sine squared is 1. If we divided both sides by sine squared, we have cotangent squared minus 1 equals cosecant squared. So we can replace cosecant squared by cotangent squared minus 1. So dx by dy is minus cotangent squared y minus 1. But cotangent y is x, so it is minus x squared minus 1. So dy by dx equals minus 1 over x squared minus 1, or in other words, someone may say 1 over 1 minus x squared. Take care. Take care. Take care. Take care. Few seconds ago, we proved that dy by dx equals 1 over 1 minus x squared. Now, dy by dx for cotangent minus 1 is the same. No, it is not the same. It is not the same. Why? As you see, in case of tangent minus 1, x is restricted between minus 1 and 1. So, this is positive value. This, why? Because x greater than minus 1 and less than 1. So it is fraction. This x is fraction. It is less than 1. So 1 minus less than 1 squared, it is a positive quantity. While in case of cotangent minus 1, x is greater than 1 and x less than minus 1. So this is positive. This is negative, so this quantity is negative. So in shape, these are the same. No. Here, as I told you, x less than 1. But here, take care, x greater than 1. Okay? Take care of this. Okay? So, d by dx for cotangent minus 1 any quantity equals 1 minus that quantity squared times the derivative of that quantity with respect to x. Okay, don't forget this. Now, for the function y equals sech minus 1x, or in other words, x equals sech y. We said before, we'll consider only that part as the principal branch, using back to right or reflection with relative to y equals x will result in that curve. Here the y-axis is vertical asymptote. This point is 1 and 0. Okay, this is x equals 0. As you see, domain, as you see, from 0 to 1, 0x belongs to 0 to 1. Range y from 0 to infinity. Symmetry, even no, or no, none. Periodicity, none. Okay, derivative, let us take in a separate transparent. Y equals sesh minus 1x, which means that x equals sesh y. Therefore, dx by dy equals minus sesh y tanh y. Sesh is x, so it is minus x tanh y. But few seconds ago we discussed that cosine squared minus sine squared equals 1. We divided by cosine squared to obtain 1 minus tanh squared equals sesh squared. So tanh equals 1, tanh squared equals 1 minus sesh squared. So I can replace tanh by square root. This is minus sesh y times 1 minus sesh squared 1. Okay, but we said that hy, so sesh y is x, so it is minus x, 1 minus x squared. This is dx by dy, but we need dy by dx. dy by dx equals minus 1 over x square root 1 minus x squared. Or in other words, d by dx for sesh minus 1x equals this. Or generally, d by dx for sesh minus 1 in a quantity equals 1 over that quantity square root 1 minus that quantity squared times d that quantity by dx with negative sign, don't forget. The last function of the inverse hyperbolic function is cosesh minus 1x. Y equals cosesh minus 1x, which means that x equals cosesh y. If you remember, we considered the principal branch of the cosesh like this, the same as the original same function. This the original function, no change. The principal branch is same as the original function. So using back to right, this is for cosesh x. This is x. While for cosesh minus 1, still same shape. Is cosesh minus 1x, the same shape. Use reflection about y equals x, you obtain this shape. Okay? As you see from the graph, as you see, domain x belongs to R minus 0, range y belongs to R minus 0, symmetry none, no, even no, odd, periodicity none. What was the derivative? Let us take a separate y equals cosesh minus 1x, which means x equals cosesh y, d by dx by dy equals minus cosesh y cotang y. Okay, cosesh y is x. What about cotang? The same relation, same golden rule. Cosine squared minus sine squared equals 1. Divide by sine squared to obtain cotang squared minus 1 equals cosesh squared. So cotang squared equals 1 plus cosesh squared. So we can replace cotang by square root of 1. This will be 1 plus cosec square y, but cosec y is x, so it is minus x times 1 plus x squared. Finally, dy by dx equals minus, which is d by dx for cosec minus 1, which is minus 1 over x, 1 plus x squared. So generally d by dx for cosec minus 1, any function, minus 1 over that function, 1 plus that function squared, d that function by dx. Alhamdulillah, finished it. Just summarize what in the derivative only, nothing more, don't worry about it. Y dash sine minus 1 over square root 1 plus x squared. In case of y trigonometric functions, sine minus 1, it was 1 over 1 minus x squared. Cosine minus 1, 1 over square root x squared minus 1. While cosine minus 1 was minus 1 over 1 minus x squared. Tan minus 1, 1 over 1 minus x squared. While tan minus 1x, 1 over 1 plus x squared. Cotan minus 1x, minus 1 over x squared minus 1. And I discussed with you, you can say these are the same, because modulus x less than 1, while modulus x greater than 1. This is always positive, this is always negative. Okay? Okay. Sec minus 1, 1 over x square root x squared minus 1. Sec minus 1, minus 1 over x square root 1 minus x squared. Cosec minus 1, minus 1 over x square root x squared minus 1. Cosec minus 1x, minus 1 over x square root x squared plus 1. Okay? And here also a plus x less than 1. Good luck, best wishes. Inshallah, next lecture we will solve together some exercise to illustrate and for more clarification of this function. Assalamu alaikum wa rahmatullahi